Good morning. Let's go to page 49 and let's go to, this is a lesson 1.7, and this lesson is to find perimeter, circumference, and area. Okay, so first let's go over some of the key concepts. So when you have a square, all four sides are congruent, so area equal to side times side, so that's s squared. The perimeter is adding the length of all four sides. So you got s plus s plus s plus s, so that's why it's 4s. Okay. Now for the rectangle, okay, so you got length, width, length, width. So the perimeter, when you add, you got 2L, so that's over here, and 2Ws, so that's over here. And area is the base times height, so it's W times L. Okay. Now the triangle, the perimeter just adding three sides, so it would be A plus B plus C. And area, it would be 1/2 base times height. So we're going to talk a little bit more about this area over here. And for the circle, the circumference, so circumference like its perimeter, but because it's a circle, so it's called a circumference. So circumference is equal to pi times d. D is the diameter. Or, because diameter is 2 times r, so when you change the d into 2r, so circumference becomes 2 pi r. And the area is pi r squared, so r is a radius. Okay. So let's go and talk more about the area. Okay. So let's say if you start out with a rectangle, I'm going to call this base and this is height. Okay. So in this case, the area will equal to just base times height. Now imagine what if I cut off like a triangle and I slide this over to here. So notice if I cut off over here, okay, if I cut off this triangle and I slide it over here, so what I end up with this shape. Okay, and this is a parallelogram. Notice I still have the same base. I still have the same height. Okay? So for the parallelogram, the area is still the same. It's base times height. Okay? All I did is I cut off this corner and I slide it over. Okay? All I did is do that. So the base stayed the same, the height stayed the same, and area stayed the same. Then that's why that's why the parallelogram and the rectangle have the same formula for area. Okay? Now, if I were to cut this in half, okay, so I'm going to continue with this. Okay, so again, right now area equal to base times height, right? Now, what if I cut this in half? Okay, what would be area of these? Well, in this case, the area of a triangle would be half of that, right? So you're cutting half. So that's how you get area of a triangle equal to 1/2 base times height. Okay, and that's where this formula, that's where the formula came from. Okay, so you can see why. If you look over here, you see why area is 1/2 of the base times height, because this is half of the parallelogram. Okay, that's where the area of the triangle came from. Okay, now let's look at the circle. Okay, so let's look at the circle. Let's see. Okay, let's just do a circle. So the circumference is equal to 2 pi r. So what they do is they come up with this, they just go and get a circle and they measure the radius and then measure, put a string around it and then measure, and that's the ratio between the radius and the circumference. Okay, it's a bifactor of 2 pi. Okay, so you can just measure it. Okay, now to find the area, imagine that if you were to cut into a lot of little tiny strips, like triangles, okay? And so you cut it and you open it up, okay? And so you're going to imagine that the triangles are very tiny, okay? So you're going to get a lot of little tiny triangles, okay? Okay. So again, I'm just kind of exaggerating. Imagine that triangles are infinitely small, okay? Now we know that the area of a triangle equal to 1/2 base times height, right? Okay. So now, so the area of a circle, you were to kind of just approximate. So again, imagine all these triangles, okay? So the height, over here, the height will equal to the radius, right? See over here, all these are radius. So the height would be the radius. And because when you have all these infinite triangles, okay, when you open it up, right, you're getting all these slides and you open it up, so this would become your circumference. So this would be C equal to 2 pi r, okay? So area of the circle would be 1/2 base times height, right? So area of the circle would be 1/2. The base would be 2 pi r, right? That's your base over here. And the height would be the r, okay? And again, the two cancel out, okay? So this cancel out, so that's how you get pi r squared, okay? Now again, this is one of the ways to show that, and there are many different ways. You can use like a calculus, you can use all different methods to kind of show you that how they get these, okay? Okay, now let's go to example 1. Okay, so you have the basketball court. Whenever you have a rectangle, you always want to label your length, width all the way around. So this is 50. So this would be 50. This would be 84, 84. You don't have to write the label until you know the final answer. So the perimeter would be adding all four sides together, so it would be 50, so plus 84, plus 50, plus 84. So perimeter would be equal to 268. Okay? And then you write down your label, so this would be feet. Okay. Now the area will equal to base times height. Okay. So area will equal to 50 times 84. Okay. I don't like to use the length and width. I like to use base times height. Okay. But they're the same thing, you know, same concept. So this one you multiply, you get 4200. Now because this is feet and this is feet, so feet times feet will give you feet squared. So you got to know your label, okay? So area is square feet, whereas the length is just, you know, feet, okay? Okay, let's go to example 2. Okay, this is on page 50. Okay, so you have this emblem over here, the patch, and it tells you that this diameter is equal to 9 centimeters. Okay, so instead of call it perimeter, since it's a circle, they call it circumference. So C stands for circumference equal to 2 pi r. Oh, by the way, when you're solving the problem, it's always good to write down the formula that you're using, and then you substitute numbers. So show your steps. So it'd be 2 pi and r would be 9/2, okay? Right, because this is diameter, so the radius would be just half of that, would be 9/2, okay? So notice, again, the reason I use the fraction, so you can see that the 2 and 2 will cancel out. So C equal to 9 pi, okay? Now sometimes you can just leave it as 9 pi, but this one they want you to approximate, so just use your calculator and multiply out, and this will give you about so once you punch in the number, because this the decimal goes on forever, so you have to chop off some digits, and therefore it becomes approximate. Okay, whenever you have to chop off digits, it becomes approximation. And if you run it off to 2 digits, 2 decimal places, this will give you 28.26. Again, don't forget your label is centimeters. Okay. Now area equal to pi r squared. So area equal to pi. Now r is 9/2 squared. So area equal to 81 pi over 4, right? 9 squared is 81. 2 squared is 4. Okay. Now again, use your calculator, you're punching the numbers, and it becomes approximate. Two wiggly line means approximation. And this will give you 63.585. So the book get 3 decimal places, so that's fine. Now this would be centimeter square. Because this is centimeter and you square that, it becomes centimeter square. So make sure you pay attention to the label, okay, the unit of measurement. Okay, let's go to example 3. Okay, so it says the triangle QRS has a vertex of Q at 1, 2, R at 4, 6, and S at 5, 2. Okay, it says what would be approximate perimeter of the triangle. Okay, so if we were to kind of graph it out, it helps you to kind of visualize things. Okay. Now, if you use graph paper, it will save you lots of time. Okay? So Q is 1, 2, so it'll be 1, 2 right over here. So that's the Q. 4, 6. So that's R at 4, 6. And S at 5, 2. And so if you do the triangle, kind of a bit off. Okay. So first, to find the perimeter, you have to go ahead and use, Pythagorean theorem or use your distance formula. Okay. So I'm not going to go through that much details. I'm just going to. So from here to here, the Q is 1, 2. So from here, this is going to be 4. Okay. So because from 1 to 5, right, it's straight across. So just 5 minus 1 give me 4. Okay, and over here I'm using the Pythagorean theorem. So this is 1, and this is 4. So this would be square root of 17. Okay, and this is 4. This is 4. 3. So 3, 4. This would be 5. Okay, again, use your a squared plus b squared equal to c squared. And again, a squared plus b squared equal to c squared. So you should know how to do that. Okay, so now the perimeter is just adding 3 sides. So it would be 5 plus 4 plus square root of 17. And if you use your calculator, okay, punching the numbers give you about 13.1. And therefore, the correct answer would be the answer C. Okay. But okay, okay, so over here, you again to get this right, you just go in a squared plus b squared to c squared. So you got 3 squared plus 4 squared equal to the distance over here. I'm going to call that QR. Okay, square. Okay, so 9 plus 16 equal to QR square. So 25 equal to QR. So QR equal to 5. Okay, that's how I get this. Okay, same thing over here. Okay. So Pythagorean theorem, so 1 square plus the 4 square. Again, all I do is just count the squares. If you look on the graph paper, you can just count it, or you can just subtract the numbers, and this will equal to RS squared. So 1 plus 16 equal to RS squared. So 17 equal to RS squared. So RS equal to square root of 17. Again, that's how I get those. Okay? So you can make sure you know how to use Pythagorean theorem and know how to use the distance formula. Okay, let's go to example 4 on page 51. Okay, so the ice resurfacing machine used to smooth the surface of ice at skating rink. The machine can resurface about 270, so the rate equal to 270 square yards, okay, of ice in 1 minute, so per minute. Okay. Now, how many minutes? So you're looking for time. Okay. The rink, it takes to, if it's the rink is 200 by 90 feet. So it'd be 200 feet by 90 feet. Okay. Now notice this is yards, so you have to convert this into yards so that this would match. Okay? So you have to divide by 3, so it'd be 3. So 90 over 3 yards, and this would be 200 over 3 yards. Okay? So you can pick a 3 feet equal to 1 yard. Okay. Yard. Okay, now first I have to find the formula. So R times time, so the rate times time will equal to the area that it will cover. Okay? So since you're looking for time, let's just go and substitute everything. So you got 270 times time equal to area. So area would be just base times height, so it would be 200 over 3 times 90 over 3. Okay? So let's go and simplify things a little bit. So you got 270t equal to, okay, the 3 and 9 will cancel out, so cancel out, you get 30, cancel out, you get 10, so it becomes 2,000. Okay, then you divide by 270 on both sides. So t will equal to, get your calculator, it's about 7.4 minutes. Okay, and that's it. Okay. Okay, let's go to example 5 on page 52. Okay, so you have a triangle. Okay. Okay, it says the base of triangle is 28 meters. The area, so area equal to 308 square meters. Find the height of the triangle. So again, write down all your information. Okay, so the picture, and it give you the information and not what you're looking for. So write down everything. Okay. Now, once you got that, then you can just try to solve. Okay. Now, since it's talking about area of a triangle, you start with your formula. You can always start with your formula. So area of a triangle. So area of a triangle equals 1/2 base times height. Okay. So write down your formula. Then after that, you substitute whatever you know. So area is 308. And whatever you substitute, you put in parentheses. That way people know that this came from substitution. Okay? And base is 28. And the height, that's what you're looking for. Okay? Okay, now all you have to just do a little bit of algebra, just go and solve. Okay? So this one you can simplify, you multiply, so you got 308 equal to 14h. Okay, and then you divide by 14, So h will equal to 22. And the label would be meters.